Hello, my name is Roy Simpson. I'm an instructor of mathematics at Cosumnes River College in Sacramento, California. This is part C of a lecture on equations of lines. We just finished talking about slope-intercept form of an equation, the slope-intercept form of a line, and also graphing linear equations that are given in slope-intercept form. And we've seen that that's pretty easy to do. Once we get used to it, not so bad. There's actually another one, another form of a line that some people like to use. I do not, but I'm providing it here for those who are interested or who have instructors that force you to go through that painstaking, horrible process, if you can't tell what I think about it. So here it is, in grandiose form. The point-slope form of a line is the equation of a line having slope m, which is the common letter we use for slope, and whose graph passes through the point x sub 1, comma y sub 1, where x sub 1 is just a variable and y sub 1 is just a variable. In this case, it's not really a variable actually. In this case, they're constants. They represent some numbers, like x1 could equal 3 and y1 equals 2 or something like that. Anyway, passes through that point. The equation is going to be y minus y sub 1 is equal to m times x minus x sub 1. So a really quick example before I'm going to prove this, because I really despise it when people just throw something up and don't prove it. Suppose you have a line with slope 3. I'm just going to use easy numbers that goes through, let's say it goes through 3 comma 2. Well, then the equation for this line in point slope form is y minus the y value, which is 2, is equal to the slope, which he said was 3, times x minus the x value of the point that it goes through, which is 3. That is the equation in point slope form. Of course, I could change this into slope-intercept form by first distributing this 3 across. You don't have to do this, but it's kind of convenient. So that's y minus 2 is equal to 3x minus 9, and then add 2 to both sides. So y is equal to 3x minus 7. That's what that line actually is. It has slope 3 and has a y-intercept of negative 7 now that I'm looking at it in this form. As the name suggests, point-slope form of a line is great to use if you have a point and a slope. Very easy to use if you have those two pieces of information. However, it's not necessary to use. Let me at first just go ahead and prove that this is the equation of a line going through that point and having slope m. And then after that, we'll do a few problems where we'll actually redo this problem without using the point slope form. That way, like I said in the past, I really despise having two ways to do something, and I'd rather you just know one thing, which is a slope-intercept form, which is the best form to have for an equation of a line. And I'll show you how to find the equation of that line just using a point and a slope as well. So let's go ahead and do the proof here. Flip a page. So the proof of this. Well, here's the deal. We know that the slope equation, the formula for slope is difference in y values over difference in x values. Right? Well, let's suppose that instead of the 2 points being x1 comma y1 and x2 comma y2, let's suppose our 2 points are x1 comma y1 and just xy. We just relabel our points, that's all. So we have these 2 points that I want to find the slope between these 2 points. Well, I'll just leave the position of x1 and y1 here, but instead of x2 and y2, I'll replace it with x and y. So this implies that we have m is equal to y minus y1 over x minus x1. Now, if you know anything about rational equations, and you should know something about them from an elementary algebra course, or you should know also that whenever I have an equation where I have fractions involved, I don't like to deal with fractions, so I'd like to multiply both sides by the LCD. In this case, the only denominator that I see is this denominator right here, the x times x minus 1. So I'm going to multiply both sides by x times x, or x minus x minus 1. I'm saying it all wrong. X minus x sub 1. All right. So I'm going to multiply both sides by x minus x sub 1. When I do that, this picture down here is the same as this picture right here, right? These two things match up, so really picture over picture, if they're the same picture, it turns into 1. So the right-hand side is just y minus y sub 1. And the left-hand side, well, I'm going to rewrite it as m times x minus x sub 1. And this should look very familiar. In fact, when I rewrite this, just swap sides just to show you, that's telling me that y minus y sub 1 is equal to m times x minus x sub 1. And that's exactly what the theorem said is the equation of the line going through the point x1, y1 and having the slope m. That was it. And if I rewind, you'll see it right here. It is literally that same equation. There we go. Now I told you, you don't need to use this form at all. If somebody says, hey, listen, you have an equation, or a line, I'm sorry, that with slope 3 and it goes through 3 comma 2, I highly recommend that you say, well, I only know one version of a line, y equals mx plus b. Gosh, I wish they gave me the slope. Oh, they did. They gave me the slope is equal to 3. So that's y equals 3x plus b. Gosh, I wish they gave me the y-intercept. They didn't. But they made it pretty easy to find it. They gave you a point that exists on this line, on which this equation represents. Well, if this point exists on the graph of this equation, then this point is a solution to this equation. That is, when I plug in 3 for x, I should get 2 out for y. And then when you look at this equation here, you'll see how many unknowns do you really have? Just the one, right? This is 9 here. I'll subtract 9 from both sides and you get that b is negative 7. Now look at this equation. Slope 3, negative 7. So there you have it. Y is equal to, the slope is 3. X, we just found that b was negative 7. And we get the same equation no matter what. I highly recommend going this route. It's the best route to work on these problems. So let's try this just one more time. Let's find the equation of the line passing through negative 2 comma 3 and having the slope negative 5/6. Well, I'm going to do this in two different ways. I'll use the point slope form. Point slope form is this: y minus y1 is equal to m times x minus x sub 1. So I'm going to replace m here with negative 5/6 times x minus, I'll replace the x value with this x value here. So minus a negative 2. On the left hand side, it's just y minus the y value, which is 3. And you can see that we get the equation y minus 3 is equal to a negative 5/6 times x plus 2. Now, often people don't like equations handed to them like this. They like it solved for a variable. So let's clean this up. Go ahead and distribute the negative 5/6 on through here. So I get y minus 3 is equal to a negative 5/6 x minus 5/3. And now I'll add 3 to both sides. So that's y is equal to a negative 5/6 x. And then 3 is the same thing as 9/3. So I'm adding 9/3 to both sides. That's going to give me a positive 4/3. Okay, so that's the equation of the line and we're done. That's using the point slope form. If you use the slope-intercept form, which again is my kind of preference as an instructor, and also just when I was a student as well, I found that knowing this one method right here, this one equation, really allowed me to save room in my brain for other pieces of information, essentially. So let's go ahead and do this one. Y is equal to, well, the slope here is a negative 5/6. But they didn't give me b. They didn't give me the y-intercept. That's okay, because they gave me a point that exists on the line or on the graph of this equation. So in other words, that point will solve this equation. So when x is a negative 2 y is going to be 3. Let's see, negative 5 times negative 2, that's 10/6, which reduces down to 5/3 actually. And 3 is the same thing as 9/3. So I'll subtract 5/3 from both sides. I get that b is 4/3. So my equation, just looking right back up here and substituting in 4/3 for that b, my equation is y equals negative 5/6 x plus 4/3, which is exactly the same equation as we got over there. Almost the same number of steps. And it's just a very convenient thing that you don't have to have two things. I'd hate to go to an exam as a student and have to memorize two forms of the same thing that both do the same thing. This is kind of ridiculous. Second kind of problem that commonly is presented to students is this one right here. When you're given 2 points and you're asked to find the equation of a line passing through them. And again, I'll do this using the two methods. The first thing you'll probably realize when you write down the equations for point-slope form or slope-intercept form is that you need a slope, period. You need a slope to do either of these forms. And they didn't explicitly give us a slope, but they implied a slope. They've given us a couple points. We can find the slope based on these 2 points. So let's go ahead and do that. And I'm not trying to pick on the point slope side. I'm just need someplace to calculate it. Remember, the slope is the difference in the y values divided by the difference in the x values. Let's say I chose 1 as my first y value, so the corresponding negative 3/13 will be my first x value, minus 2. Now let me tell you something here. I'm trying to simplify this number, and when I have fractions within fractions, basically whenever you see a fraction, you almost always kind of think LCD, LCD, LCD. And I'll tell you, when I look at this complex fraction, I see, oh, I have a numerator that has a fraction that has a 4 in a denominator. I have this ultimate denominator here that has a fraction with a 13 in it in the denominator. So the LCD amongst both the numerator and the denominator is 4 times 13. That's the common denominator between the numerator and the denominator of the major fraction. So I'll multiply top and bottom by 4 times 13. Notice that when I'm doing this, I'm not changing this fraction at all. 4 times 13 divided by 4 times 13 is just 1. I'm not changing this fraction at all. I'm going to distribute that number, whatever that product is. I'll distribute it across to each of these items here. And you'll see in the numerator, I get 1 times 4 times 13. So in other words, what is that? 52. Minus, and then 1/4 times this number. Well, the 4's will cancel, so I'll just get minus 13 upstairs. In the denominator, when I distribute the 4 times 13 across, the 13's will cancel in the first fraction, so it'll just be a negative 3 times 4, or a negative 12. And then I have this 52 times a negative 2, so that's a negative 104. A horrible number, but it is what it is, right? Okay, so we'll go ahead and do some subtraction here. 52 minus the 13 is, what is that, 42/39? And negative 12 minus another 104 is 116, negative 116. And as ugly as it is, this fraction is not reducible. So I'll write upstairs negative 39 over 116. Notice I put that negative in the numerator. Now again, I could plug this into the point slope form, but at this point I'm tired of using the point slope form. I'm just going to go right over here and use the slope intercept form. Slope intercept form says that I just need to replace that m with negative 39 over 116. And now I just need to know what b is, and I can find b by choosing wisely the value that I'm going to plug in for x? Well, no matter what, I think you're pretty much going to make your life a little bit miserable here. But with a little forethought, I'm going to go ahead and plug in this point. You can plug in either one, you'll get the same equation. Okay, both these points sit on the graph of this equation, so both of them will satisfy the equation. But I'm going to do that first point. I'm going to let y equal 1, and oddly enough, I'm going to let x equal negative 3 over 13. You might wonder why. Well, the reason why is because 13 happens to go nicely into 39 three times. So I knew that those two were going to cancel. Negative 3 times negative 3 is positive 9, so this gives me that 1 is equal to 9 over 116 plus b. The number 1 is a very nice number because that's the same thing as saying 116 over 116. And now I'll subtract 9 over 116 from both sides, and I will get 107 over 116 is equal to b. Now I have all the pieces of information I need to rewrite my equation as y equals the slope times x plus b, which we just found to be this horrible number. But we're done now. It could be worse, right? But it's like I said, I didn't need to use a point slope form at any point here. I just stuck with using the slope-intercept, and I highly recommend, unless your teacher forces you to use the point slope form, I highly recommend that you always use the slope-intercept form. Now, I would be highly remiss if I didn't mention this. You can always create your own problem sets just by going to Googling Wolfram Alpha, or not Wolfram Alpha, I'm sorry, Wolfram demonstrations. In fact, let me write that down. If you just Google, and I'm not paid by these people, but it's a free thing anyway, so Wolfram demonstrations. Just Google that. The first one that comes up is the Wolfram demonstration site. And you can search for little applets and things that you can play with. And this one is titled Slope and Equations of Lines Through Points. If you just type that, once you get to the Wolfram demonstration site, if you type that into their search box, this will be one of the two results that pop back. And you can now drag these points. Well, once you download the player, you can drag these points and you can, create any problem you want, really. Let me do it this way. So you could just you could drag the points to wherever you want, and you could test yourself. Try to find the equation in line that goes between those 2 points. And once you do, you can then say, you click on this button that says slope-intercept equation, and it'll actually tell you what the equation is. Point slope equation. You can only select one for them, but there it is. So you can it'll tell you the equation so that you can play around with this. And it's very nice. And you can also view the line going through. So do all this stuff. And if I check this, you can see the equation here changes as well. So very interesting, and you can play around with this if you want.